Hi, this is Mr. Word. I'm going to do a short video on word problems in the intercept form and how the intercept form can be used to model things. So here we have the basic intercept form, x over the x-intercept plus y over the y-intercept equals 1. But how would this apply? Well, x-intercepts are often a starting or ending time. Starting or ending whatever the independent variable is, time is often a good one to work with. And y-intercepts are often starting or ending places. So let's do some examples and see if we can illustrate that. So example 1, you started with 80 pancakes to eat, and 30 minutes later you had finished all the pancakes. So starting with 80 pancakes, pancakes are the number of pancakes you have to eat is going to be an output. So I'm going to call that 0, 80. Y will be 80. And then time is going to be an x input. So we're going to have an x-intercept at 30, 0. So we have a starting place of 80 pancakes and an ending time of 30 minutes. So now we have an x-intercept and a y-intercept. We can model this. If I zoom out a little bit, we can actually see those. If I put a comma in there, that'll actually plot the points. Okay, so there are a couple of points. I have to zoom out a little more so you can see the top one. So that's how many pancakes you have at the start. You have no pancakes after 30 minutes, so 30 minutes is your end time. So we can set up an equation with x over that x-intercept plus y over that y-intercept equals 1. And the only thing we'd really want to add in is a restriction because you won't have negative numbers of pancakes, and we don't have any information about pancakes you had before 80. So let's just restrict this to from 0 to x is 30. And there we have a model for any number of pancakes you might still have to eat at any particular time. So after 12, we get to see if I can get to a nice and tidy number. I might have a hard time doing that. But basically, after 11 minutes, you have 50 and 2/3 pancakes left to eat if you're eating at a steady rate. In example 2, 6 hours ago, you left home. After 10 hours, you arrived at your, I need to redo that one. So I rewrite that again. So after 10 miles, you arrive, I'm going to change that to, 10 miles. You arrive at your destination, the world's largest ball of string. So I had a little error in how I wrote it because I had them both be times. So let's start over. 6 hours ago, you left home. After 10 miles, you arrived at your destination, the world's largest ball of string. So this is a time 6 hours ago, and so that'll be a negative time. We'll treat that as an x-intercept because that's a starting time, negative 6 hours, 0, 6 hours in the past. Negative is often backwards in time. And after 10 miles, you arrived at your destination. So that is your ending point. At 0 is your ending place, 10 miles, and distance is an output of time. So here we have y-intercept, it's our ending place, and an x-intercept, that's our starting time, and we can create an equation with those things. So the x over the x-intercept plus y over the y-intercept will equal 1. And that will represent our journey. And we might want to restrict it so that it's just our journey from 6 hours ago to now 10 miles later. So we'll say negative 6 is less than or equal to x is less than or equal to. Notice if I just hit the less than and then the equal sign, it gives me a less than or equal sign, 0. And there we have our journey 6 hours ago to the world's largest ball of string, 10 miles later. Now here's a third example. Today you owe Jimbo $540. After steadily paying him off, you will owe him nothing 300 days from now. I'm going to have to zoom out a little bit for this. So we need our starting place, which is owing $540. So we owe $540. Owing money is generally considered negative. So that's going to be of course, that's a starting place. So that's a y-intercept, 0, comma, negative 540. I need to go this way, 0, negative 540, and we'll label it. And then our x-intercept is the point when we owe nothing. So the output becomes nothing 300 days from now. So there is an x-intercept and a y-intercept. I'm going to flip those in position. Okay, so we'll flip those in position so it helps us remember which one is the x-intercept and which one's the y-intercept. So we say, so 300 days from now is our ending time, and $540 in debt is our starting place. And being in debt is sometimes called in the hole, and so that is negative. So we'll say x over 300 plus y over negative 540. Oops, let me rearrange that. Okay, plus y over negative 540 equals 1. And there we have an equation. We can restrict it if we like. So x would be 0 is less than or equal to x is less than or equal to 300. And we have restricted it. We now have a model for how much money we owe at any point in the future between now and 300 days. By the way, this negative here could be moved here if you like the equation aesthetically. However, in some ways, it's a little better to leave it here because it reminds us that that is an amount of debt that we have at that point. Either way is fine. I hope that helps.